My name is Roberto Martínez. I work for BBVA at the Innovation Labs, that is the department. And I'm going to talk about parasitic computing, an introduction to parasitic computing with BrainSlug. So, what is parasitic computing? Well, it's a programming technique where one program that is communicating in a normal fashion with another program manages to get the other program to perform a computation. Okay. This was first proposed in 2001 by the Department of Physics and the Department of Computer Science in the University of Notre Dame. And they managed to solve this very large and extremely difficult three-SAT problem, parasitizing the TCP stack of a remote web server. But what is a three-SAT problem in the first place? Well, it's a problem that you have given a very complex Boolean expression like that one, and you have to this Boolean expression is formed by variables and Boolean operators and some parentheses, and you have to find if there is any combination whatsoever of values for those variables to make the whole expression to evaluate to true. So this kind of problems can be very, very difficult and NP complete. Another thing that you have to know to understand this is that one property of the TCP checksum function is that it has enough logic for implementing any Boolean operation, basically, and by extension any arithmetic operation. So we are computing with the TCP checksum function. They do that to solve this three-SAT problem. And the way they managed to resolve this problem was by just by splitting this very large Boolean expression into very simple Boolean operations that match the capabilities of this TCP checksum function. Afterwards, they encode this smaller Boolean operation into TCP packets. So they manage to force the other computer to perform this computation for them. And the way they did it was by first opening a normal TCP connection to a web server. They establish the connection normally, and then they forge this package by just encoding the smaller problem into the TCP payload and the checksum. In a way that if the TCP checksum is correct for the data that's in the packet, also the Boolean operation is true, and vice versa. Okay. So what happened is if the guess that they are doing for the Boolean operation is correct, what happened is that also the checksum is correct. And, of course, the packet is pushed up to the HTTP web server. But this kind of packet is not a valid HTTP packet. So the server response is an error. But is enough information for the parasite to know that, the guess is true, is correct. What happens if the guess is not correct? Of course, the checksum will be also incorrect. So the TCP stack will drop the packet at the TCP level without pushing it to the HTTP level. So they, after splitting this very big problem into smaller problems, they send in parallel all those HTTP packets with the guesses, only the correct solutions are answered by the server, so they managed to solve this problem. So 1 year later, a student of the University of Applied Science in Bern, Switzerland, made this virtual machine that used this technique to basically compute any kind of program. So yeah, if you want to use free resources, you can compile to this for this virtual machine and just run the problem with the free resources of the internet. Yeah, we have free computer power, guys. So let's mine bitcoins and be rich, basically. But no, not so fast. That's why. That's because the cost of encoding the problem into TCP packets is way higher than solving the problem in the first place. So, parasitic computing seems impractical, but has some very nice features. For example, logic protection. I mean by logic protection that the host that we are using to compute can discover what the parasite is computing. That's because the parasite is not sending any kind of algorithm to the host, just using it as a resource for the computation. Also, another really nice feature is the host readiness. I mean that the host is already available in the internet, and the resource is just there, sitting there. So there was no need to install any special software in the host, just using it. And this is because the parasite is clever enough to encode the problem in a way that the host is understanding. The last feature is the host resources themselves. Just in the case we have seen, there were the problem that the CPU was not very well used, but computers are much more than just CPUs. They have hardware, and by hardware I mean memory, storage, and special hardware like GPUs, etc. And they have networking capabilities because maybe they are connected to another network we are trying to access. And also, they have data inside that maybe is interesting for us. So, the question really is, can we make it practical? And the author of the original paper suggests that as one moves up the application stack, there might come a point where there is a computational gain to the parasite. So, up we go. I really like you to make this exercise and think about the host that we were using in the example as a kind of a virtual machine. And if this TCP checksum function were a virtual machine, this will be the properties, and the properties are that the instruction set of this virtual machine is very limited, because we just can compute Boolean operations, and we only could access to the CPU of the host. But if we think about an ideal virtual machine for our parasite to take advantage of, we would like to have a high-level, richer instruction set. I mean by high-level, like in a programming language, a very high-level stuff, and richer, really a big variety of instruction that we can perform in the host. And also, we'd like to access any resource that the host has, like hardware, network, or any data. So, my conclusion is that dynamic languages are the perfect target for parasite computing. Why is this? Because they offer the same features that we discussed before, like logic protection. how they offer logic protection. Well, dynamic languages have this eval function that we are very familiar with. And using an eval function, we can execute very small pieces of code. So using this, we can perform just that. They also provide host readiness, and I mean that dynamic languages are everywhere. In every system, I think there are at least a cell, and a cell is a kind of dynamic language in a way. And also access to the host resources. Dynamic language makes easy to access any kind of resources. They are very high level languages. So, thinking about that, we developed BrainSlug, that is a framework for parasitic computing. It's an open source project that you can see in GitHub at the official repo BPPA. And BrainSlug allows users to write normal looking Python programs that use the resources from external dynamic languages, from external interpreters. And for understanding BrainSlug, we have to understand the terminology that we use. And the first thing that I like to show you is the slug. The slug is the name that we give to the parasite. And the duty of the slug is to control the program flow and make translation between the Python interpreter that we are running the program on and the remote dynamic language. Okay? And the next thing is the zombie body, or just the body. The zombie body is a small script in the remote language, written in the remote language that we want to control, that is in charge of communicating with the slug. This is the pseudocode for a very normal body. And the first thing it does is download some code from the slug via HTTP, evaluate the code using eval, and sending the result of the evaluation back to the server via the same HTTP request. And when sending back the result, it will download some new code, and it will repeat the same loop over and over. Okay, I don't know if you can read this. This is a very simple body for BrainSlug written in Bash, in shell script, and it's exactly the same algorithm. The first thing we do is make this request. Sorry. Make this core request, sending the variable res that initialized to empty, to an empty string, to the slug, and this will download some new bash code that we will evaluate using the $symbol parentheses stuff of the cell, and this will hopefully generate some result that will be assigned again to the res variable, and this loops repeats forever. It's clear enough? Yeah? Okay, so hello world in BrainSlug. The things that we have here are the same two things that we just saw. We have in the left-hand side the code of a slug, and in the right-hand side we have the same the body, the code that we've seen. This is the code in the left-hand side of the slug. As you can see, it's a very normal Python code. We are importing some stuff from the BrainSlug library, and we are declaring this function, hello world function, that is decorated with this Slug decorator. This just tells the system that we need, for running this Slug, we need a body attached to us. Okay? And this body is gonna be named remote. Okay? So this remote is the body attached to us. And last, we run this hello world function through the run function that we import. And when this is running, the remote has this print function inside that will print hello world in the host, in the body, okay, in the zombie body. The next thing we have is exactly the same code that we saw before. And with this, we can we have the system making a hello world, okay. And how it works behind the scenes? Well, we have here exactly the same code. In the left-hand side, we have the slug. In the right-hand side, we have the body. And they are talking to each other. The first thing we have to do is to initialize the program, the slug. We do this in the parasite side. And the first thing it does is wait for the body, because we are trying to run this function that needs a body. Without the body, it can't run really. So when the body connects via HTTP, because of the curl that we are making here, the slug executes start execution until the body is needed, and it's very, very quick here in the first line, the print of the hello world. So in this moment, some bash code is being generated by the slug and sent back by the HTTP request to the body. The body receives this bash code, evaluates it, and in this case, there is no result to the echo, of course, but an empty result is sent back. And this operation continues forever, or until the slug is closed. It's clear? Yeah? Okay. So we are going to see a demo. The first demo is a Parasitic remote desktop. So you can think about this like a PNC server or PNC client. But the difference is that we are implementing this in BrainSlug. And again, we have two parts, the slug and the body. The slug, in this case, will ask the body for screenshots continually to have this sensation of video. Okay, and we will see this video through a remote web server. Sorry, a remote a web interface that the slug is opening for us. Also, the slug will forward any mouse or keyboard interaction through this web interface to the body. And what we have in the body? In the body, we have exactly the same code that you saw in Bash, but of course in PowerShell. Okay? This is a remote desktop for Windows. And it's all you need. PowerShell is the only dependency here. A standard PowerShell. Why is this? Because PowerShell is capable of taking a screenshot of the whole screen, and also is capable of moving and making clicks with the mouse. Okay, so first demo is gonna be a little bit dark. Okay, we have here three Windows. I hate you. We have here three windows. In the top left, we have a virtual box with windows. In the right-hand side, we have a normal Chrome browser, and in the bottom left, we have a Linux console with the Python program. Here we have the the code is just 86 lines long, and it's just a standard Python. So we run it. Okay, and the first thing it does is wait for the body. Okay, so to get the body running here, because this is PowerShell, I have to open a PowerShell window and write here some code. I'm not writing here the whole body code. I will just ask to BrainSlug for a launcher. We can get this code by, I think you can see that the URL is just the URL of the Slug, /launch/PowerShell. And it will give us this small PowerShell code. This is the smallest possible PowerShell code for evaluating some code for some reason. And here in the PowerShell console, I paste the code if it wants to. Okay, but as soon as I press enter, here down, the program continues, and it's opening another web interface for us, for the client of the BNC, of the remote desktop, sorry. And it's opening the port 1891. So here, in my browser, I can enter in localhost 1891, and I'm entering in the web server that the BrainSlug is opening for us. So at this moment, in the right-hand side, I don't know if you can see it, we have a terminal session, and we can interact with it. It's a little bit slow, but it's functional. We can write hello world. Sure enough, this is happening, of course, in the Windows machine. Okay, so if I move the mouse in the right hand side, you can see with some lag in the left hand side the mouse moving, and this is all happening by sending small pieces of code through the network to the PowerShell loop and evaluating. Okay, so there's any kind of software installed really in the Windows machine. Okay, continue. So the second demo. The second demo is a Parasitic remote browser. It's exactly the same, but exactly the same code in Slug, no changes whatsoever. But we are changing the body. Instead of a PowerShell body, we are using a JavaScript body that will load some JavaScript libraries on demand by the Slug and taking screenshots of a browser. It's not really possible to take a screenshot of a browser because there is no JavaScript API to do that. But there's this JavaScript library, HTML2 canvas, that renders renders a DOM into a canvas, so it can provide the screenshot for us. So in this demo, I have here, instead of a Windows virtual machine, I have another browser, and the same browser in the right, and the same console in the bottom. So I execute the code. Sorry, I have the Windows body running. So I execute the code, and the same happens. It's waiting for the body. But this time, I'm going to use the body of the JavaScript body. So I have to download the way to launch it, And this is the same. Instead of writing launch PowerShell, I write launch browser. And instead of having an ugly piece of PowerShell code, I have this link. If we see the code, it's just a JavaScript link that we can use as a bookmark. So I will drag it, drop it here to have a bookmark. And now I can navigate to any website. For example, for reference, this first one, and I will click this share screen, and this will launch the body inside the browser. So when I click on the link, the same happens. The port is open, so I can here enter the same address, 1891. And instead of seeing a Windows machine, we are seeing the browser on the left. So here, if I, in the browser on the left, write something, hello, BSides, you can see in the right-hand side, the session being drawn. Okay? Any questions? Oh? Okay, moving on. So what sorcery is this? The same program with two languages. Well, BrainSlug is not magic, of course. Some work has to be done in order to translate between Python and other languages. And is the thing that we are going to see now. So how you can define new bodies with BrainSlug? Well, you have to declare a boot function that is the one that will return the source code of the body that we see before. And this is the source code. The first thing we have to do is define this thing we call ribosome. Is an internal object of BrainSlug. This ribosome is like a collection of functions to define an external language. And the first thing you have to do is declare the root of this collection. In this case, I am declaring the bash language. So I declare and I generate this object bash, and I define with this decorator just a function that returns the bash code that we saw, but instead of hard coding here the URL of the slug, we have to provide a way of getting it dynamically. So here we are receiving the URL, and this is, by the way, Python 3.7. So I'm using the new way of interpolation, F strings. So here you have the URL. And how you can add functionality to this body? Well, you have to do exactly the same and define function with this decorator define. These functions have the responsibility of encoding and decoding from and to the external language, and have to use this double underscore eval double underscore function. That is the one that sends the code back to the body to be evaluated. So in this case, okay, in this case we are defining the print function that we saw in the example. We have to define bash.print, okay, decorating this function. The name of the function is not relevant, so here I use the underscores. All of these ribosomes, that is the name of those functions, receive a remote, that is the same object that we are using in the slug. So we can call any other function that we have. And the rest of parameters of the function. In this case, because this is the print function, we are receiving the text that we want to print. And with the double underscore eval function, we are translating this code to bash. So it's an echo, and we are using the escape function that we've seen to perform the quotations. So in summary, when you would like to use BrainSlug, you want to use BrainSlug if you need any of those three properties, or the three of them, that are logic protection. That's because all the program logic is in the slug. None of the program logic will be sent to the host. If you need host readiness, because you want to execute some program without it installing anything in the body, just using remote interpreters, no deploys. And finally, to access the host resources occasionally, this is not the best way to access the resources for everyday use, but occasionally is a way. And the last thing I want to say to you is that you can contribute. You can write new bodies and new ribosomes for BrainSlug, and you can even without our intervention distribute these bodies and ribosomes as Python packages. So you don't need us for that. And that's all I got. Thank you.
Mind blowing.
Questions?
Any questions?
Are you assuming cooperation of the zombie machines, that someone's going to run a command to allow it to become a body?
Well, if there is cooperation, technically it's not parasite computing. So you have to provide a way of accessing the interpreter to be parasite computing, because if not, it's just distributed computing. But for the demo, I have to just make something simple. So, yeah.
So it would be maybe some other exploit to...
Yeah, maybe some remote code execution or something like that. Yeah. Of course, you can use it the same way I did. And these have some benefits too. For example, that you don't have to deploy, or you don't have to reveal your logic to the other party. So, yeah, maybe it has its own benefits.
Any other question? Don't be shy. I know you're tired.
So does the zombie then need to have like complete code execution, or would you be able to like break a payload into multiple steps? Maybe you could get part of it run like.
Well, you have to have access to the full access to the interpreter.
Okay.
To run the initial code, and after that, any other code is just evaluated. So I don't know if I answered your question.
But then once you've got the framework in place, maybe it's easier then to develop. Things on top of that would make it.
This can. This doesn't have to be the only way to exploit the host. This is just one way that maybe in some occasion is useful, because you don't have, for example, access to write anything in the disk, so you can't deploy a script and then run the script. Here, everything is on the fly. Nothing was written to the disk. So
yeah, it was really cool. It was just hard for me to follow at the start because it seemed a lot like just distributed computing, as you say.
Yeah, it's really the difference is more philosophical because distributed computing you have to put all those pieces in place to make the computation very optimized for the task. This is more oriented to some environment where you don't have really the benefit of this deployment, or this I don't know, this way of working. So yeah, maybe other use cases, but it's very related, yeah, to distributed computing. Any other question? No? Okay, thank you.